So thanks for joining. We have quite a crowd. So my name is Mitya Pino. We're from the Confio team, and what we wanted to talk a little bit about today is the new tracing tool that we just announced recently. So maybe since there are a few of us, let's maybe start with the intros. What do you do, guys? Why are you interested in this thing? So we can maybe adapt the story a little bit.
You could.
Okay. Yeah. But still, at least.
Fraser and I are from Checked, so Cosmos project.
Cool.
I look after the product side of things. Fraser's the boss. CEO.
Just me. But we're, I guess, a couple of bits. Like, we know at some point we're going to do more complex commercial models, which will need probably coding in CosmWasm. But we're also going to have like credentials where we bring proofs. Like the credentials are off ledger, but we bring proofs on ledger through like into CosmWasm contracts.
Yeah.
So we could have things like permission DeFi. We could do like lending based on like external credit scores. We could also do like better governance, so your governance is based on roles or experience as opposed to staking.
Yeah.
All of which is, it's going to probably be in CosmWasm across various networks.
Yeah. Good stuff. Yeah. So the reason why we started working on this thing is because there's basically a tooling problem in the CosmWasm ecosystem. And historically, Confio's role was to work on the core of the CosmWasm stack, let's say, rather than the tooling. And we just like talking to the developers, we figured out that there are quite a few issues that they kind of continuously have across the board. There are basically like two groups, like debugging related and testing related. So this is a solution for the debugging part of the problem, let's say. And so the problem is that there are kind of multiple aspects to the stack. There are the smart contracts themselves, then they work with different chains. The chains have Cosmos SDK modules, they're different. There are some modules that are unique to the chains. And when you debug your smart contract, you have to be aware of what's going on all these levels. And this is why it's basically a rabbit hole. And what we're trying to do is helping developers to get into this rabbit hole, let's say in a structured way, so kind of red pill the developer ecosystem a little bit and help them instead of like getting some very generic errors, or maybe in this case no error at all in the Explorer, get something more detailed and understand the structure of their transaction essentially. So that's the problem we're trying to solve, and tracing is the proposed solution. So what it does, it basically dissects the transaction. So in this case, this is something hugely complex. There are maybe like 50-ish different what we call spans within, or different operations within a transaction. And what this tool allows you to see is what are all the spans, where are the errors, what are the logs that relate to every each of these operations, and then you can deal with it in different ways. So if you just want to debug it, you see, okay, here's the error, it's red, I can kind of click into it and see the details of the error. If I want to optimize towards the gas, I can go into the details of the operation and see the gas. And that's basically, the motto is that we allow the developers to know their transactions, so they know all the errors, they know all the operations, they know what's the gas usage in the transaction, and they know the sequence of the call that the transaction consists of. So that's the idea of the tool. And so what we're gonna do with this today is Pino gonna talk a little bit about how it's built, and then we're gonna do a demo, and then we go just an open discussion about it. So that's the plan.
Sounds good.
Yeah. So I will give an overview about how the architecture looks like. So basically we have four main components. The instrumented node, there is basically the RPC node that you all know, but is a modified version because it has some instrumentation that basically extracts some data and sends them to the Jagger collector. It is just an open source component that are just a task to store this data to the database. Then we have the database, we are using Elasticsearch for performance reason. And then we have the Jagger query. There is another component that just fetches the data from the database and displays them through the UI. This is like the basic, setup, the basic architecture. It is let's say scaled horizontally, and we got help from our technical partner, that is Reno. So thanks Reno for that they basically supported us in building the architecture, and they're actually running the infrastructure for us. At the moment, we have like mainnet and testnet for 3 chains that are Terra, Neutron, and Kujira, and we are looking to integrate more. Oh, I closed.
Interesting.
Why is it so aggressive?
Is it also the connection or the source?
I think we just switched off. No?
You went to the source. Maybe.
Okay. Yeah. So going into a bit more into the implementation details. So before I said that this instrumental node basically collects data, and so how we do that is basically we instrument some parts of the code. At the moment we have we instrument the handler, begin and docker, contract messenger, and all the IBC related operations. And we call these operations because then in the UI that you will see later, you can basically filter by these operations and see basically, you can decide like what to filter for. Then we have tags. Tags are just basically keywords that help to efficiently search, for example, the transaction, the block height. We have this tag called error rate that is basically a boolean that if it's true, then you can search by the transaction that contains an error. It doesn't mean that the transaction failed, but it means that there is an error inside, maybe some message failed or something like that. And then we have also contract and sender contract. These are really nice because and useful because basically when you search by contract, you can basically monitor your contract and check, for example, the performance, see what is the latency, the throughput, if it's maybe still matching the expectations or is getting delayed. And another thing you can do is, for example, search for the error rate that you're getting. So maybe, I don't know, at some point your contract is timing out too often, maybe there is an issue and you can monitor or fix bug. And this is a limited set of tags that we have, but we are looking actually for more use cases from people that are actually going to use it, so that we can increase this set of tags and help people find elements that are useful for them.
And sender contract is so that you could, like, if you've got strings of contracts calling each other.
Yes.
Okay.
Yes. So basically, we can search when that contains the sender. And this is like the main part of this tool. Is basically all this data that I mentioned before. So basically, each of these operations has these so-called logs. Is the collection of all the data that we were able to extract for that operation. And for now, what we are able to extract is like storage reads and writes, logs, events, raw errors. So we are able basically to, as Mitya said before, to check. For example, if you have contract A calling contract B, calling contract C, and you get a failure in contract C, you're not going to be able to see what happened unless the error is propagated back to contract A in a proper way, and that usually doesn't happen. With this tool, basically you are able to check, okay, what is happening behind the scenes, and And then you can check also for messages, payload response, contract interaction, as I said. And also you can monitor gas usage. So yeah, you can fine tune also that. Yeah. So back to Mitya for the demo.
Oh yeah, thanks. Yeah, so let's have a look at the tool. Okay. Now I know the problem. It was not plugged in properly. Okay. Yeah. So this is what it looks like. So let's have a look at what we have in terms of the areas. So on the left is search. So that's basically different inputs to navigate across the transactions. On the right there is a like simple graphic for transaction duration, so you could see outliers there, for instance. And then there's just a list of the transactions, and in this case it actually could be pretty long. So this is the result of your search, and you could click into any of these, and then you will see all these details that we were talking about. But first, let's see what we have here. So yeah, so as we said, we support 3 different chains, so mainnet and testnet for each of them. And one of the next steps in the development of this thing would be to create like a version of it that you could deploy locally. Because a lot of debugging actually happens before you go to testnet or even to mainnet. And this is why, like what we heard a lot from developers is that they want to have this for their local environment. So this is one of the next things to work on. Actually, the other one is purpose-built UI. This is kind of generic, so it provides you a look into the data, but it's not very optimized towards CosmWasm use cases. So that's something that we're working on as well. But for now, at least this UI shows you what data is available in the tool. So here you can filter out all these operations that Pino was talking about. And yeah, as we said, they're kind of across the Cosmos SDK modules. So a bunch of them are coming from the CosmWasm module. So some of them are kind of generic, so like end block, begin block, IBC related modules, IBC related operations, and so on. So you can pick one, and you can filter basically on what's going in this particular operation, and that could be useful as well when you're looking for errors of a particular type. But in this case, we're just looking for all the errors that happened in Kujira mainnet in the last couple of days, and this is basically it. And so here's a bunch of the transactions, and you could just click into each one of them. So this one at the top is an interesting example because it has a lot of errors, it has a lot of spans, so that's going to be something fun and complex. So when you go into it, you see all these operations, and as I said, like this is a lot going on here, and you see all the errors highlighted. So you could navigate directly into one of them and go into logs and go into error object, and now you can see the details of the error. So that's basically kind of the flow, let's say the primary flow, how you can work with this tool. And I want to show you a few examples where this gets really interesting with some specific errors. So let's have a look at this one. This was in Neutron rather than Kujira. So this is an interesting one because this is where the so-called error reduction happened. So this means that when smart contracts talk to each other, so imagine there is smart contract A, smart contract B, there's smart contract A calls smart contract B, and there's an error in smart contract B. So for now, smart contract A doesn't really know the details about this error, and this is built this way on purpose because the error could be kind of specific to a certain machine, and then if you have these errors like in different nodes, they will break consensus. So to protect the chain from that, the errors are reduced to something that would be consistent across the machines. And this is why when you look into the Explorer, you can only see a generic error. So it says, okay, like query contract error, something, something, execute wasm contract failed. And this is exactly the problem that we're trying to solve. Now when we look into tracing, we can see details of all these calls. So here is this operation that was failed in the smart contract B. So this was a query which was called by another smart contract. So this is smart contract A, this is smart contract B, this is where the error occurred, and these are the details of the error. So it was in CosmWasm STD. You see the error details here, and this is exactly what was not available in the Explorer. So you guys came at the redacted error example, my favorite. So 5 seconds version of it is just an example of the error that we see in tracing, which is not visible in the Explorer because the error was redacted. Well, that was in your tweet, by the way. you said, "Are you guys tired of generic error messages?" So this is exactly the thing. Yeah. So basically, using tracing, a developer can doesn't have to deal with this thing. They can go into the details of the transaction and see what the actual error was about, instead of trying to guess. We had an interesting example with a team that is building on Osmosis, and this was when the thing was in let's say early beta stage in December. So they had a mainnet error that they could not navigate exactly because of error reduction. So they were receiving like a generic message. They knew that we were working on this thing, so they reached out to us. They said, "Can you figure it out?" We had to kind of restart it for Osmosis mainnet, but essentially we sent them the link to the trace. They found an error. They said like in 15 minutes, and their estimation that it would have taken like 3 days if they were to figure it out without the tool, because basically the process would probably be kind of guess what exactly were like the data that caused the crash, try to replicate the same data in test environment, and then kind of see what the actual error was about. Yeah, and a couple more examples. Let's see what was interesting here. Okay, so that's another example. This is where the Explorer says the transaction was successful, and in fact there was an error, and I think in this case that was an IBC transfer error. So basically what was going on, there were like multiple messages that were happening in parallel. There was one of them that had an error. It didn't cause the transaction to fail, and you cannot know it if you're looking at the Explorer. And actually, I don't know what people are there any tools that would allow people to figure out these types of the errors? But this would be very easy to miss, let's say. So these are kind of a couple of examples, and I think I'll just stop here and ask you if you have any questions or comments about it, and let's just discuss this thing. Yes, I have a question then. So for those of you that have used have built CosmWasm contracts, what's the most painful thing?
Well, we thankfully haven't touched them yet. But we have a lot of painful things with Cosmos SDK itself. So Lex can tell you some more stories from that.
Some very, very special systems.
I'm curious.
So of course, events are sometimes really messed up. Sometimes they have bugs in the SDK which were tricky. We've luckily caught before we deployed it and stuff like that. Especially if you want to do reconstruction with the events, or try to reconstruct from state, especially if do text analysis and stuff like that. It's something that's really tricky. For example, tricky examples, for example, the delegate event does not emit the delegator, but it does emit the sender event later on. However, if you do for example, off-C execution, then stuff gets mixed up, and it's very hard to determine the actual delegator, for example, for delegate event.
Stuff that should be straightforward.
They fixed it in v4.7, but a lot of changes in v4.5, v4.6, and even if you want to analyze the past, it's pretty painful.
We had, for example, we also had stuff on Osmosis. So we do archival data, right? And we're for some old block height around 2.5 million to 3 million of Osmosis. Depending what RPC node you would ask, would actually get different events. So some had a transfer event that other nodes hadn't, but there was no consensus error or something like this, so must have been some bug on flushing the event log or something like this, and then we called it and we were oh, what's going on there, what should we do? And so that's kind of like stuff we thankfully haven't touched too much CosmWasm yet. We got a little traumatized from other things, but honestly the tool looks amazing. It's something we could have
So,
used a lot.
are you guys looking to integrate CosmWasm? What's your
So
plan?
but when we have to, then we will do it. But luckily, we didn't need it to answer now. So
We're on it.
Like
We're on it exactly. And so I mean, yeah, it's I don't know. I love this space so much because stuff like this, like I don't know, if like the transfer goes through, normal user thinks everything is well, and then you're like, no, we need like special tools to find out like didn't work, right? And then how does that work? I don't know. It's like there's like fun things happening, right? Or also if you look on MinScan, for example, for Kive at least, the number of addresses that MinScan says are on Kive doesn't match with what the chain says.
Oh.
The chain says like 12,800 whatever addresses, and MinScan says 11,970, and another explorer we have for Kive says 10,000. And stuff like this.
Average it out.
It's always fun.
Yeah. Yeah, sure. So yeah, let's see. We had a couple of more examples here. So let's see what I think. Okay. Yeah, that's an interesting one as well. I think that's another one where there's that's a successful, well, allegedly successful transaction according to the explorer, which again has an IBC transfer error, and I think that's as long as we kind of play with this tool, I think that's one of the patterns when if you have kind of parallel IBC calls happening, that's kind of often that we see a transaction that would contain an error somewhere that wouldn't be visible in the Explorer because it doesn't lead to a failed transaction, but you wouldn't see if like the error was there in the first place as well.
I have a quick question actually.
Yeah.
How would that look like on the user side of things? So if I would interact with the contract, the transaction would go through. What would actually happen with the failed part underneath? It just wouldn't. I just would never know that it didn't work, or.
Yeah, basically yes. So you would see it as a successful transaction, and then something would not happen what you would expect to happen implicitly, and then you would find out later on with some weird thing that you would be figuring out in parallel.
I think we've had that on our network. We were like bridging across a gravity, and then basically like something didn't happen on their end. The whole thing unwound, but we couldn't see it.
Mm-hmm.
So from all our analysis was like, oh yeah, we've definitely bridged these tokens across, but they'd actually never gone because they'd gone and come back, but we had nothing to show that was the case. And it took us forever to figure out what the hell was going on.
Yeah,
really weird.
yeah. That's the next one to work on, by the way, because the IBC transfers they often could be buggy. And what would be cool is to create a version of it that looks at both chains and kind of tracks ABG transfer end to end. So that's something that we want to work on in the future. But the plan for us is to kind of trace more chains because like we need pairs to be there. And then, there's definitely a way to start matching these, let's say, pairs transactions. And I think, like generally speaking, kind of cross-chain use cases would be really good to navigate with this tool, because it would be tricky otherwise.
So, we mentioned we're going to have a case where we have like proofs off ledger being brought on ledger into CosmWasm contracts, but then like the way I think you kind of know this, like we've got something on the network which is just a module which is for revocation registries. So we'll end up with like a CosmWasm query coming across IBC onto our network that then interacts with a module, but we actually don't run CosmWasm ourselves.
Mm-hmm.
I'd be really curious how that would work in this scenario, because like this is something we're likely to see a lot of issues with, is like making queries in CosmWasm that route across IBC, then they hit us, but we're not running CosmWasm at all.
Yeah.
And therefore, like how to trace it through would be really
so
interesting.
that would be a contract on the other chain, or?
Yeah, and then but doing an IBC query.
Okay. Yeah, so for now, we actually had a look at like a few examples like this. So for now, that would require some, let's say, research. Basically, you know some parts of the transaction on one chain, and you could kind of guess what was the counterpart of this transaction on the other chain. So I think when we did it recently, how did you find the other?
Yeah. So basically, there was this chain. They were trying to send to do this IPC operation to the other chain, and they tried multiple times until it succeeded. The point is that we were able only to see the one that succeeded on the other side, most likely because it never reached the other side. The ones that failed, they probably failed on their own chain, and it reached the other side because then we were able basically through these tags, basically finding, okay, what is the contract that you have called, and what is the operation? Okay, is IBC receive? Okay, then you filter out of this thing, and then also you can filter by time, it's time span. And then
is anyone here a relayer? I'd be super curious if you ask those guys like what they need help with, because that stuff is a mess and no one seems to understand what's going
So
on.
that's the finance here, like in this room, but like they had a chain,
Because
they're on the relayer.
that seems to be like stuff goes wrong there all the time, but no one really knows what's going on, and eventually just like it gets flushed out or someone like really analyzes it, but it takes way too much time for what it is. I'm curious if that would be something this could go into as well.
Yeah, I think with relayers, another level of complexity is that they were, at least for a long time, they were almost like a hobby things for some of the validators or info providers. But I think there is a shift now because some of the chains now do some kind of grant or contract for people to actually support relayers reliably. Especially testnet relayers is a big pain. No, that's a good idea to talk to them and see what they could get out of it.
Sorry, I walked in late, so I don't have all the context. But my understanding of what I'm looking at is a call graph for some neutron chain transaction. And I was wondering, because I guess gas metering has always been a mystery to me in CosmWasm. So I'm wondering, are you rendering anything related to is the horizontal distance here gas consumption, or what is the?
So in this case, this is duration of the operation, but there is a gas log in the tool. So here, for instance, you see a breakdown of the gas cost for a given operation.
Gotcha.
So we collect this log as well, and that's actually one of the interesting use cases for this thing, because so far we kind of focused on error detection. And I think another would be gas optimization.
My project uses Tenderly, which has similar functionality for the VM side, and that's one of the most useful features is
absolutely. They have a nice kind of gas breakdown graphical view.
Yeah, exactly.
Yeah. That's I think what's done really well in Tenderly.
Do you think off the back of doing all this analysis, whether you'd be able to start proactively preventing some of this stuff? If you, because I guess at the moment everyone's reading error messages and trying to guess. But if you've got everyone using this tooling and you can take logs off the back of it and almost turn it into something like Linty, where you just start preventing people from screwing up before they even do it.
I mean, so do you mean in a transaction simulation way, or just kind of monitoring?
Well, maybe it's even, I guess I don't know to what this is going to go, but even coaching them on something they're writing in code which you already know is going to break because you've seen it so many other times.
That's actually what's kind of happening. So the way it works for us now, so it's kind of part of the package that we deliver to the chain teams, so they would be the user and also the developers that build contracts on these chains. And sometimes they would be asking us, okay, I see this error, and for instance, what happened recently. So they had an overflow error, and one part of the solution was kind of detect where exactly it's happening, and kind of they could do it with tracing. But And the other part was kind of us recommending them basically using different CosmWasm functions to deal with the with multiplication, for instance, to prevent overflows, or at least to handle errors better. So yeah, I think once you start realizing what errors exactly are, there is a kind of pathway to improve your practices. Yeah, that's for sure. Yeah. Cool. All right. So, any other
Is this
questions?
tool public right now, by the way?
Yeah.
What networks are you on?
So it's now it's for Terra, Neutron, and Kujira, yeah, we're going to roll it out to more chains, for sure, and yeah.
How's that working? Like, are you going after community grants, or like, how's...
It depends on how they. I mean, sometimes it's a grant, sometimes it's just a foundation contract, something like that. Yeah. Depends on what works for them. Yeah. Cool. And yeah, the tool is public, so you could go to to this link, tracing.cosmwasm.com. There's no login; you just go there and play with it.
Can you just you can't just point it at an RPC. You need to.
Oh, because it's an instrumented node. So we
Running
host the
right
RPCs or like the nodes. So that's a full node that collects rich logs and puts it into a separate database. So that's kind of what enables better kind of data collection.
Yeah, I'd be curious to hear more about that.
Yeah, absolutely. And we can. I think we're technically kind of at time, but we can just, I don't know, step out. I'll show it to you. Yeah. All right.